Hi everyone, welcome to Numeric Learning. In Do Math with Me, in the daily practice questions today, we have a set of questions from Chapter 1, Real Numbers. The first question for the day is, if A and B are two co-prime numbers, then A cube and B cube are. The options are co-prime, not co-prime, even and odd. So let's do it with an example. Suppose you have got the two numbers A and B as 2 and 3 respectively. Okay, so what do you mean by co-prime numbers? Those set of numbers whose only common factor is 1, right? So here if you see, the factors of 2 are 1 and 2. The factors of 3 are 1 and 3. So 1 is the only common factor between 2 and 3, and that is why they are called as co-prime numbers. Right? So if you have A and B as any two co-prime numbers, then always remember the HCF of co-prime numbers of any two co-prime numbers is always 1. So HCF of A and B is always 1. Now if you take the cube, A cube and B cube, cube of the given numbers. So what is 2 cube? It is 8. 3 cube is 27. Again, if you see the factors of 8 and the factors of 27, you will see that 1 is, so let us do that. So for 8, what are the factors? You have 1, 2, 4, 4 twos are 8, and then 8, right? For 27, what are the factors? You have 1, you have 3, you have got 9, and then you have got 27. Right? These are the factors of 8 and so which is the only common factor? Again 1. So if you take the HCF, so 8 and 27 are also co-prime numbers, and if you take the HCF of A cube and B cube, that is also 1. Okay, so the answer is going to be, if A and B are any two co-prime numbers, then the cube of those numbers are also co-prime. So the option is A. Okay, A cube and B cube are also co-prime. So please remember this, right? Therefore, A cube and B cube are co-prime numbers. And also remember the fact that HCF of any two co-prime numbers is always equal to 1. This is also something which you have to remember, right? So please make a note of this question if you are a student of class 10th. Okay, these are the kinds of questions that are frequently asked in exams. So it's always good to be prepared and to do. Okay, if you just look at the video, maybe for the time being you will feel as though you are able to understand, but then eventually if you get a question, if you are not making a note of it, it would be difficult for you to remember it, keep in your mind and revise it also. So please take a notebook, follow the daily practice questions that I'm giving you, and I am solving it with you. So spend 20 minutes to 30 minutes every day solving questions with me. Pause the video and please solve it. Okay, so let's move on to the next question. In a formula racing competition, the time taken by two racing cars A and B to complete one round of track is 30 minutes and P minutes respectively. If the cars meet again at the starting point for the first time after 90 minutes and the HCF of 30 and P is 15, find P. A very straightforward question. So you are already given that the two racing cars A and B take, in order to for them to complete one round of track, A car takes 30 minutes and B takes P minutes, right? And the cars meet again at the starting point for the first time after 90 minutes. So what does this mean? Always, if the car has to, how long it will take for them, for each of those cars to complete one round, and the time taken for them to meet again at the starting point is always going to be a time greater than the given time, right? It's always going to be greater than 30 or p minutes. So what is this 90 minutes given is the LCM, right? So what you are given is LCM of 30 and p is 90. This is 90 minutes, right? 90 minutes. And you're also given HCF. HCF of 30 and p minutes is equal to 15, right? So why is the LCM 90? You have to know that since the cars they meet again at the starting point after 90 minutes, therefore the LCM of 30 and p is 90. So this is one. Normally this 90 minutes, this is the value that most of the questions will ask you to calculate, right? The time taken for B to complete one round will be given to you, and 90 will be the value which will be asked. But here it's the other way around. You should know that if the cars meet again at the starting point for the first time after 90 minutes, then what is this 90? 90 is going to be the LCM of the two values, 30 and P. HCF is again 15. It's definitely going to be the same unit, because 30 is also in minutes and P is also minutes. So HCF and LCM value will also, the unit will be minutes. Now we know the relationship between LCM, HCF and two numbers. What's the relationship? The product of LCM and HCF is nothing but the product of the two numbers. So let's plug into the formula. LCM is 90, HCF is 15, is equal to one of the number is 30, the other number is P. So P is equal to 90 multiplied by 15 divided by 30. So 3 3s are 9, and 3 multiplied by 15 will give you 45 minutes. Unit is very important. Okay. So find P. P is equal to 45 minutes, right? So such questions can normally come for a 2 or a 3 mark question. And the most important thing in this question is about you translating this sentence, that is, cars meeting again at the starting point for the first time after 90 minutes. You should know this is what is the LCM. So that is the main highlight of this question. If you are able to figure out that 90 is the LCM, HCF is already 15, then it's probably straightforward. LCM is given, HCF is given, one of the number is known, you can use the formula, right? So please make a note of it. Let's move on to the next question. You have to prove that root 2 is an irrational number, right? Prove that root 2 is an irrational number. Very frequently asked question. Let's learn it using a method which is called as a contradiction method. Do it with me. In place of root 2, even if you are asked root 3 or root 5, root 7, it's going to be the same. So let's do it. Let root 2 be a rational number. We are assuming it as a contradiction statement. Let root 2 be a rational number. Okay. So if it is a rational number, root 2 can be written in the form of P by Q. Here you have to make sure that you are writing P and Q are co-prime numbers, where P and Q are co-prime numbers and Q is not equal to 0. Instead of writing P and Q are integers, we are being more specific by saying that P and Q are co-prime integers or co-prime numbers, meaning that P and Q have only one common factor, that is only 1. So P and Q have only 1 as a common factor. So this is the assumption that we are proceeding with. Now what you have to do? Squaring both the sides. Squaring both sides. So you'll be getting root 2 the whole square equal to P by Q the whole square. Every step is important. So 2 is equal to P square by Q square, or I can write P square equal to 2Q square. What does it mean? 2 multiplied by some value is equal to p square. So it means 2 divides p square, or which implies 2 divides p. Right? So let this be 2, let this be 1. Right? So if 2 divides p, it means that p is equal to 2c. Okay? So p is divisible by 2. So p equal to 2c. Now put this in 1. So what do you get? When you're putting 2c in equation 1, replace p with 2c. So 2c the whole square equal to 2q square. So 4c square equal to 2q square, or q square equal to 4c square by 2, which is 2c square, right? So this shows 2 multiplied by some value is equal to q square. So 2 divides q square, which implies 2 divides q. This is equation 3. So what do you see? You see that 2 is a factor of p, or 2 can divide p, 2 can also divide q, which means what we assumed is wrong. P and q do not have just 1 as a common factor. P and q also have 2 as a common factor. So write down from 2 and 3. From 2 and 3, what do you see? 2 is also a factor of p and q. Therefore, this makes our assumption wrong. This makes our assumption wrong. What we assumed initially, that is root 2 is rational. So we assumed root 2 is rational. So this assumption is wrong. Therefore, root 2 is irrational. Root 2 is irrational, hence proved. Right? So this is a proof which you have to actually spend some time and learn it. If you are able to learn for one of the values, root 3 and root 5, you just have to do it the same way. Okay, so let me explain it once again. Okay, so you have to prove that root 2 is irrational. We will be using a method which is called as contradiction method. Contradiction method. Okay, so let's assume that root 2 is root 2, let it be a rational number. So rational means it can be written in the form of p by q, where p and q are co-prime and q is not equal to 0. What do you mean by p and q are co-prime? That means p and q have only 1 as a common factor. So squaring on both the sides, root 2 the whole square equal to p by q the whole square. So 2 equal to p square by q square. Cross multiply, you will be getting p square equal to 2q square. So if 2 multiplied by some value equal to p square, means 2 divides p square and 2 divides p also, which implies if 2 can divide p square, 2 can also divide p. Right? So if 2 divides p, p equal to 2c. 2 multiplied by something is giving you p. So p equal to 2c. Put this in equation 1. So you have 2c the whole square equal to 2q square. Open square it. So you have 4c square equal to 2q square, or q square equal to 2c square. So if q square equal to 2c, which means 2 divides q square, that implies 2 can divide q. So from these two, what do you see? 2 is a factor of p, 2 is a factor of q. So 2 is also a factor of p and q, but in our assumption, we thought that for p and q, only 1 is a common factor. So this makes our assumption wrong. Therefore, root 2 is irrational. A very simple, straightforward, but you have to actually practice the same steps, all these steps. With probably you can take a root 3 and practice, do the same thing, and root 5 also. Okay. Let's move on to the next question. So Pooja multiplied a number 484 with a certain number to obtain the result 3823A. Find the value of A. So this A is nothing but a unit digit. Okay, so 484 multiplied by a certain number, let it be X. So here 484 multiplied by a certain number is giving you a number which is 3823A. Find the value of A is the question. Now, what does it mean when you say 484 multiplied by some value is giving you 3823A? That means 484 is a factor of this number, right? Whose unit digit is unknown and you have to find out. So, therefore, you can say that 3823A is divisible by or can get divided by is divisible by 484, right? Or you can also say that 484 is a factor of 3823A. Now let us factorize this 484 further. So when you are doing the prime factorization, start with 2. So 2, 1, 2, 1, again 11, 11s are 121, right? So 484, when you factorize it, it is 2 square multiplied by 11 square. So what does it mean when I say that 484 is a factor of 3823A? That means if 3823A is divisible by 484, then the same number should also be divisible by 2 and 11, because 2 and 11 are the only prime factors of 484. So let's write that. That means 3823A should be or is divisible by both. So what have we written here? 3823A is divisible by 484. Now if it is divisible by 484, we have just expressed 484 as a product of prime factors. So 2 and 11 are prime numbers. So 3823A is divisible by both 2 and 11. Correct? Now, which are the numbers? What should be in place of A? Let us first only take 2. Okay, so let's first check for only 2. If a number has to be divisible only by 2, then this A has to be an even number. So, if the unit digit, only if A is even, right, that then A could be what? Either 0 or 2 or 4 or 6 or 8. Then it is divisible by 2. Then the number is divisible by 2. So, what are the possible numbers in case if 3823A has to be divisible first by 2? So, the possible numbers are 38230, 38232, 38234, 38236 and 38,238. These are the only possible numbers which is divisible by 2. Among these 5 numbers, you have to tell me which number will also be divisible by 11, and that will be your final answer. So you will have to actually divide each of these numbers and see. Divide this with 11, divide this with 11, and whichever answer you are out of these 5 numbers, definitely one of the number is divisible perfectly by 11. You have to find out which is that number, and I will leave this to you. Okay, that's the last step. You have to write the answer in the comments. Among which is that one number which is also divisible by 11? So comment the answer and I'll respond to you. Okay, you have to divide each of the numbers by 11, and whichever can perfectly divide without leaving a remainder, that answer. So suppose if you are getting this as your answer, right? This is the number which is also divisible by 11, then A is 4. Suppose if you are getting this is the only number which is divisible by 11, then A is nothing but 6. Okay, so the unit digit is what we are being asked, right? You are only asked to find out A. So do it and see, divide each of the numbers by 11 and comment your answer, right? The last question for the day, you have to prove that 2 plus 5 root 3 is an irrational number. Very easy again. Again, let's go with the contradiction method. Let 2 plus 5 root 3 be rational. So 2 plus 5 root 3 can be written in the form of P by Q. Here let's write it as P, where P and Q are just integers and Q is not equal to 0. 5 root 3, let it be on the left hand side, take 2 to the other end. So P by Q minus 2, take LCM. So you have Q, P minus 2Q. So 5 root 3. So root 3 equal to P minus 2Q divided by 5Q, right? So P is an integer, Q is also an integer, so and remainder is also an integer. So this is going to be a rational number and this is going to be a irrational number. And irrational cannot be equal to rational. Therefore, this makes our assumption wrong. This makes our assumption wrong. Therefore, 2 plus 5 root 3 is irrational. Hence proved. Very straightforward question. You just have to equate it to P by Q. Root 3 is the only irrational number. Retain first of all the entire term on the left hand side. Take 2 to the other end. Take the LCM and then make sure you have only the irrational term to the left hand side. Take 5 to the denominator. And you can say that irrational is not equal to rational. This makes our assumption wrong. Therefore, the given number is irrational. That's all. It's a very, very straightforward question. In case if this comes for a 2 marks or 3 marks, you will get full marks for it. But always make sure you don't just leave it here. This should not be the final step. This should not be you have to write, therefore, this makes our assumption wrong. The given question or the given number is irrational, hence proved. This is very, very important. Make sure you are writing till the end. Pause the video. Please do all of these 5 questions and let me know in the comments if the video was useful, if you learned something new, and if there was any part of the video which was difficult for you or wherein you had a doubt or there was some clarity missing, please post it in the comments and I'll definitely reply to you in the next DPB or tomorrow's video solution. Let's continue doing this till the end of the year, every day, 20 to 30 minutes, solving problems chapter wise. Happy learning and thank you so much.